Hello everyone, let me introduce myself first. So my name is Muhammad Januar Indra Praja and I'm come from Indonesian University of Informatics and Business. So today I'm gonna present my research that's titled Security Testing of the Research Collaboration Community Conference Website Against DDoS HTTP Flood Attacks using the NIST SP 800-115 framework. Now let's begin from the introduction first. So, distributed denial of service or DDoS is a common type of cybersecurity attacks that targets availability of a website or a system, something like that. And one of the kind of the DDoS attack is HTTP flood. And the object of this research is RCC conference website that is still in the stage of a development and it's not yet in public for use. So the objective of this research is testing aims to assess readiness against attacks, the DDoS attacks, and the goal is to give the developer recommendations for the security of the website. And the focus of this research is the login and registration page of the website. Okay, this is the methodology. So this picture right here is, I took it from the NIST SP 800-115 framework that consists of 4 phases, that is planning, discovery, attack, and reporting. And we're gonna discuss it later. And the tools that I used in this research is GoldenEye, Slowloris, Nmap, EtherApe, TCP-DOM, VNstat, and HTOP. Okay, first we enter the planning phases. So in these phases, we define the target, that is obviously the RCC website, especially the login and registration pages. And here we set the attack parameters and durations, and we prepare the monitoring tools on server and attacker VM. So each on the server and the attacker virtual machine has its own monitoring tools. And then we enter the discovery phases. And in these phases, there's this tool called Nmap that is used for identifying open ports and running services. And then in this discovery of the baseline or normal traffic, we use the EtherApe, TCP-DOM, VNstat, and HTOP tools. And based on the results we gathered, that in these discovery phases there's no unusual activity before testing. It's because we haven't do the attack. And as you can see in the left picture, that is showing the log of or results of the Nmap that towards the server IP. And as you can see, it tells that the host is up, so the website is up. And then the right one is the TCP-DOM log, or the results. So it shows that there's 10 packets captured, like in this 1 minute of capturing. So there's not much happening because the attack is not even it's not even happening. And then we have the EtherApe interfaces in the left, and it's only like a bit of line, and there's nothing else because there's nothing happening right now. And then below it is the VNstat. It records hourly, and in the time of 5 seconds, the traffic and the receive and transferred happening, like in right now, like the 5 seconds of the time. And then the right picture one is the HTOP interfaces that shows the CPU, memory, load, and everything that is happening in the website, the server one. And then we enter the attack phase. So in these phases, the GoldenEye tools, the attacker, it directs the attacks the login and register pages with 20 agents and 20 workers. So it's basically like 400 packets or traffic, so it is big, and it's observed in the time of 2 minutes. And then the Slowloris one, the Slowloris one, you can only attack from the IP, and you attack it directly to the pages with consists of 1,000 sockets, and we observe it in a time of 5 minutes because slow loaders is slower to take impact than the GoldenEye. And both of these attacks is monitored via server-side tools, the tools that I've mentioned before. And then the last phase is the reporting phase. In this phase, we do some documenting of the traffic spike and resource usage, and then from the results we gather, the GoldenEye has that CPU and bandwidth surge, so it degraded the response of the website. And then the slow loaders one, the effect is negligible on performance, so it's barely taking any significance than the GoldenEye. Okay, so we enter the results, and this one is from GoldenEye. As you can see, the right picture, it's we attacking the login page right now, and as you can see at the right bottom, the htstop interface. So the CPU is already higher, like at 90%, and then the loads and everything is higher because the attack is really heavy. And then the Ether Ape too, like it's not just a line anymore, like it's the whole screen of the Ether Ape is yellow, so because it is that the attack is that heavy and big. And this picture is basically the same, but it's only on the register page, so it is the same that it's taking effects of the DDoS attacks like on the login page, so it is the same. And then here we have at the left is the TCP dump log, and this is captured like under a minute. So for under a minute, it's already capturing 70,000 packets. So it's really big, it's really heavy. So because it is really that crazy, the DDoS attacks. And then the right one, it's the VN stat, and as you can see that you can actually look at the hourly stats that the latest at the 10 p.m. it is shown that it's the traffic captured is bigger and heavier than the beforehand. And here we have the results of the slow loaders. So the slow loaders is different, and as you can see in the picture, in the htstop, the VN stat, and the Ether Ape, it's not really taking much a difference on the performance side. So it is not that big compared to the GoldenEye, because what it takes is this minimal CPU or bandwidth change, and then the service of the website is no disruption. And as you can see, the TCP dump logs too, this is captured in 1 minute, so it's only 8,000 packets compared to the 70,000 of the GoldenEye, so it's really, the difference is really big. So the conclusion and recommendation we have for this research is that GoldenEye is effective and the impact is bigger than the slow loaders, and slow loaders is ineffective under this current setup. And the RCC website security needs an improvement for DDoS resilience. And then the recommendations for the developer is to implement one of these is either .htaccess rules and mod evasive. So it's a configuration that you can set in like Linux web server based like that. And then we recommend the developer to continuously monitoring, because you'll never know when the attack is happening, so better to careful. And this is some reference I take for my reference for my research, sorry. And this is my contact person if you wanna contact me or ask me a question about my research. And that's all from me. So thank you everyone for the participation, and thank you for the attention, and as always, thank you.